Welcome to the lecture on Advanced Calculus and Numerical Methods. In my previous lecture, I discussed about how to find the solution of non-homogeneous partial differential equations by using direct integration method, and also how to find the solution of homogeneous partial differential equations with respect to one independent variable. In this lecture, I am going to discuss few more problems related to the homogeneous and non-homogeneous partial differential equations. So first I am going to discuss one example related to the direct integration method. The problem is dou square z by dou x into dou y is equal to x square y, given z of x comma 0 is equal to x square and dou z by dou y of 1 comma y is equal to cos y. So given equation is dou square z by dou x into dou y is equal to x square y. So call it as equation number 1. So now we have to find the value of z by eliminating this dou by dou x and dou by dou y. So for that I am going to integrate the given equation with respect to x and y. So now to eliminate this dou by dou x first, we have to integrate the equation number 1 with respect to x, treating y constant. So we have to represent the constant in terms of the arbitrary function having the y variable. So if I integrate this equation with respect to x, I'll get dou z by dou y. Integrating x square with respect to x, I'll get x cube by 3 by keeping the variable y as it is, plus constant will be f of y. So call it as equation number 2. Again, to eliminate this dou by dou y, I am going to integrate this equation with respect to y, treating x constant. So after integration, we will get the equation like z is equal to integrating y, I will get y square by 2. Already x cube by 3 was there, so I will get x cube y square by 6, plus integrating f of y, I will get capital F of y. So the formula for f of y will be integration of f of y dy plus constant is g of x. Call it as equation number 3. So now we have to estimate the constants capital F of y and g of x to get the complete solution. So I am going to replace the given initial conditions here. So first I am going to replace dou z by dou y is equal to cos y, and here given x comma y, so x is equal to 1 they have given, so replacing x is equal to 1 and dou z by dou y is equal to cos y in this equation. So if I replace that condition, so I will get cos y by 3 plus f of y. So I got small f of y is equal to cos y minus of y by 3 on replacing x equal to 1 and dou z by dou y is equal to cos y. So now I want to estimate the value of capital F of y. So capital F of y is given by integrating small f of y with respect to y. So if I integrate this equation with respect to y, I will get integration of cos y minus y by 3 into dy. So integration of cos y will be sin y and y by 3 will become y square by 6. So now to estimate the value of g of x, we have to replace z is equal to x square and y is equal to 0 in the equation number 3. So before that we have to replace the value of f of y also in this equation to get the g of x value. So now I am going to replace y is equal to 0 and z is equal to x square in this equation, along with f of y is equal to sin y minus y square by 6. So if I replace that condition, I will get x square is equal to 0 plus 0 plus g of x. So g of x will be equal to x square. If I replace this g of x value in the equation along with f of y value, I'll get z is equal to x cube y square by 6 plus sin y minus y square by 6 plus x square is the required solution. So we'll see one more example related to the homogeneous partial differential equation with respect to the one independent variable. The problem is dou cube u by dou x square dou y minus dou u by dou y is equal to 0. Given that u is equal to x square by 2 when y is equal to 0, dou u by dou y will be equal to 0. Dou square u by dou x dou y will be equal to y when x is equal to 0. So I'm taking the given equation first, that is dou cube u by dou x square dou y minus dou u by dou y is equal to 0. Call it as equation number 1. So to make the equation very simpler, I'm going to replace dou u by dou y is equal to v. So if I replace this condition, I'll get the equation of this form. So it will be very easy for the computation of the given partial differential equation. So I'm going to replace dou u by dou y is equal to v. So it will become dou square v by dou x square minus v is equal to 0. I will get it. I'm going to convert this partial differential equation as an ordinary differential equation. So like I will get d square v by dx square minus v is equal to 0. So now we can simplify this ordinary differential equation by converting d by dx as capital D. So I will get d square minus 1 into v is equal to 0. So now we can make an auxiliary equation to find the root. So I'll get m square minus 1 is equal to 0 is an auxiliary equation. By simplifying this equation, I will get the roots like m is equal to plus or minus 1. So now the solution of the ordinary differential equation, this equation, I will get v is equal to c1 e power x plus c2 e power minus x. So actually I want to represent the solution in terms of partial differential equation. As I told that we have to replace the constant in terms of the other independent variable as an arbitrary function. So I'll get the solution of the partial differential equation 2 will be equal to v is equal to f of y e power x plus g of y e power minus x. I will get it. But previously I took v is equal to dou u by dou y, so I'm going to replace that equation back. So I will get dou u by dou y is equal to f of y e power x plus g of y e power minus x. Call it as equation number 3. Actually we have to find the solution for u. So now I'm going to integrate this equation with respect to y to get the value of u here. So if I integrate the equation, the value will be u is equal to capital F of y. So integrating small f of y with respect to y, I will get dy, keeping the constant e power x as it is. Similarly, integrating small g of y with respect to y, I will get capital G of y by keeping the constant e power minus x as it is, plus one more constant is h of x. Call it as equation number 1. And also to satisfy this condition, I'm going to differentiate dou u by dou y equation with respect to x again. So I'm going to differentiate this equation number 4, equation number 3 with respect to x. So I will get dou square u by dou x into dou y. So differentiating the equation with respect to x, I will get f of y e power x, keeping f of y as a constant. Differentiating e power x, I will get e power x only, and g of y I am keeping as it is. Differentiating e power minus x, I will get minus of e power minus x. Call it as equation number 5. So now we have to estimate the constant one by one by the given conditions. So first I am going to replace dou u by dou y is equal to 0 when x is equal to 0. So what will get it? So I will get, if I replace that condition in the equation number 3, I will get f of y plus g of y will be equal to 0. So when dou u by dou y is equal to 0, when x is equal to 0, I got f of y plus g of y is equal to 0. Similarly, from the equation number 5, I am replacing dou square u by dou x into dou y will be equal to y when x is equal to 0. I got this equation. So y is equal to f of y minus g of y. On simplifying this equation, we got f of y is equal to y by 2, g of y is equal to minus y by 2. Now to estimate the value of h of x, we have to use this equation. To estimate this h of x, actually we need to represent the constants f of y and g of y also. So from the obtained f of y and g of y, I am going to estimate the value of capital F of y and capital G of y. So capital F of y is given by integrating this small f of y with respect to y. I'll get y square by 4. And to estimate capital G of y, I am going to integrate this small g of y with respect to y. I'll get minus y square by 4. So now I'm going to replace these two values in the equation number 4 along with the condition what they have given here actually. they have given the condition like y is equal to 0, u is equal to x square by 2. So I'm going to use this, that condition, the equation number 4, along with the value of capital F of y and capital G of y. So if I use that condition, y is equal to 0 and u is equal to x square by 2, I got the equation like h of x is equal to x square by 2. So now replacing all these values in the equation number 4, h of x, capital F of y and g of y, the solution will be like u is equal to e power x y square by 4 minus e power x y square by 4 plus x square by 2. By taking y square by 4 common factor, I'll get e power x minus e power minus x by 2 plus x square by 2. So it will be equal to sine hyperbolic x. The solution will be u is equal to y square sine hyperbolic x plus x square by 2 is the required solution for the given partial differential equations. Thank you.